We're going to finish our interval notation here for just a second. Again, whenever you're doing interval notation and graphing, a couple things to keep in mind. Is we always want to have three numbers on our graphs to show our number sense, that they're equally spaced, so there's an equal amount of value between each one. And also between that, just a couple of things with our symbols. So again, we remember if it's just less than, like it is in this case, we'd have the parenthesis working. The bracket comes when we've got the or equal to. So since x is less than, we talked about how less than is going to go to the left. So I'd have my parenthesis. I'd be going off to the left because that's where my values of x are getting to be less than. And when we do the interval notation, though, we always write it in looking at the graph from left to right. So since left is heading forever to negative infinity, since the numbers are getting lesser and lesser, until I come upon this endpoint here at 8, and then I can just use the symbol that I have. And again, if I head off to the right forever, like I would in 21, I just use positive infinity because I'd be going to the right forever and ever. Okay. Find the inequality for the given solutions. Again, we've got examples of all three of these up above, but just again to kind of get thinking about it again, we talked about the keys. If I see negative infinity, I'm going to have a less than inequality. If I see a positive infinity, it's going to be greater than. So I look here, for instance, on 22, and I say, okay, negative infinity means I'm going to have a less than. So I'd have x is less than, but I also notice there's a bracket here, which means it's or equal to 1. And if I think about it, okay, all my values at 1 and going less. Negative infinity, if I were to have a number line here, negative infinity up to 1. I don't have to have the little graph, but if it helps you, that's okay. Okay. And how this comes into play is, especially with the interval notation, is when we switch over to the actual work that goes along with it. I've got to grab the correct note sheet here. There we go. And we go to solve these. Bring this down a bit. And again, this would be the notes that we've got involved here. We talked about the interval notation already. And the only difference between these and an equation, actually, is a couple of minor rules. If I multiply or divide both sides at the end to get my variable term by itself, I have to reverse, or I have to flip the inequality arrow. Now, that doesn't happen a lot, but it does happen occasionally. So when we get into doing these, solving this actual inequality, solve it just like you would an equation. So I'm going to add the 8 to both sides, and I'm going to divide by 5. Didn't divide by a negative, so everything's pretty prototypical and standard. And then I just do what we've been doing on the rest. Get my number line made with my minimum of 3 numbers, and even if you'd have done like 2, 3, 4, that'd have been fine. 4, 5, 6, as long as the number's in there. So then questions. What symbol am I going to use, and what direction is my arrow going to be going? Yes, ma'am.
You're going to be using a parenthesis and you're going to be going left.
All right. Yep, parenthesis because it's just less than. And we're heading to the left because it's less than. And then again, my interval notation that goes along with that goes from left to right. From negative infinity to 4. And I'm done. I'm good to go. So don't make things too complicated here. When I get to the next one, now again, nothing too bad, but here'll come the catch. My first step is to get that positive 5 out of there. Don't get sucked in by seeing the negative. We're going to minus 5 to both sides. And then, and I'm actually going to draw this one out this time to draw a notice to it, I'm dividing both sides by the same negative number, the situation we're talking about up here. Whenever that happens, I've got to remember to reverse or flip my inequality arrow. Because if I don't, I'm going to get the exact opposite of the solution set that I want. And again, when you're using the negative numbers, be careful when you're labeling your number line. We don't want to get sloppy and make it like -10, -11, -12. But otherwise, we're in a pretty similar situation than we were in the last one. Except we're going to use a bracket, and we see that it's less than. So there's our bracket. Less than will head off to the left. And once again, we basically end up with the same type of interval notation, except now my -11 gets included because of the bracket. Again, never any brackets on infinity of any sort. And then finally up here, and then we'll start bouncing around a little bit here to see what's up. Whenever you've got the fractional ones, we always want to isolate that term first. So before you go dealing with the 3/2 here, let's get the 7 out. And again, whether you choose to multiply by the reciprocal, or you're like, yeah, I'd rather just multiply by 2 and then divide by 3. That's fine. So the reciprocal can take care of it in one big swoop. 9 times 2 is 18, divided by 3 is 6. And then again, just getting all of our parts set up with this, except now x is greater than. Arrow's eating x. Parenthesis, greater than. My numbers get bigger, so they head to the right. And again, when I go left to right, this time the leftmost point of my graph is my starting point at 6. And I'm going off forever to the right to positive. Make sure that comes out right. Positive infinity. And the only other thing really that changes as we go along through here is some keywords and what things look like. So for instance, let's say we're looking at number 5. It's just a little bit more of a compound. It's going to have a few more steps. But all of the rules still are going to end up being the same. And when you distribute, make sure you distribute all the way through. And some of you may like having a positive x value. Some of you may like having the x on the left side better. Because when we have the x or the variable term on the left side, then we can basically follow the arrow along. So let's say we decided we were going to go that route. If I brought my -4x over by adding it, oops, that's going to be negative still. And we'll all get to the same answer no matter what. So if you added 5x, keep going. You'll get to the same place. I'm going to minus my 5 over. And I did it this way this time because I just wanted to reinforce this one more time. If your x, which isn't positive and ready to go yet here, if we have to multiply or divide both sides by a negative to get my variable term alone, and we do here, we've got to remember to flip the inequality arrow. And then again, once you get there, it's not as big of a deal. X is less than, arrow's pointing at it, which means we're heading to the left. And again, since we go left to right, we start at negative infinity and move to our furthest point to the right, -7. But always be watching, because if that x happens not to be on the left side, we've still got to recognize if it's less than or greater than. And then we'll just get you a little start here with ands and ors, and then we should be in pretty good shape getting you at least a start here. So compounds, okay. Ands and ors and figuring out what they look like. This would be an and problem. Okay, it's a compound inequality. And what it happens is we want to know the values that cover everything, that are both greater than or equal to negative 2, and less than 1. So if I look at those separately on here, and we did something like this yesterday, if x is greater than or equal to negative 2, okay, if I were looking at this, it would be going to the right because it's greater than, but at the same time, I want values where x are less than 1, which would be a parenthesis, and those would be going back to the left. And what happens is they end up taking all the values in the middle, which happens most of the time with and statements. They come together, sort of like two cars or two trains crashing together. And then that's interval notation will basically just be the endpoints and their symbols. So if you either see the word and with two separate ones or see a compound, that's typically how it's going to work. The only other option we run into, for the most part, if we flip over here, is if we see an or in the middle. And a lot of times those will be split. Okay? Ors typically go out. So I graph each one separately. X is less than negative 1. All right, there's my parenthesis. Less than goes to the left. Or x is greater than or equal to 2. Greater than goes to the right. And you see there's a separation point. They go out from each other. Now, writing this one in interval notation is a little more interesting. She's like, now how am I going to show there's a gap here? Well, I'm still going to go from the leftmost point to where it stops for the time being. But then I'm also going to write another part where it starts and go to where it ends. And to let the person that's looking at this problem, that those are all part of one problem, we need to combine them, which is called a union. So we put the U in the middle to say, yeah, I want both parts of this as my answer. Not just one or the other, but all of it. Okay? So again, and I'll just do one of each of these. We'll be done. We'll have you pretty well set here. Even though I'll put a full done copy on the website in case you want it. Whenever you get these and inequalities like this that are three-parters, make sure whatever you do that you do it to all three parts. So for instance here, if I want to get my x alone and I want to add 3, I need to add 3 to all three portions. Whoops, I'm not dividing, silly man. And then divide by 3, because it's all about getting that x alone in the middle. And now it's just like everything we've been doing every other time. I still want to have my numbers going in a notation though. So again, you can do that any way you want. You could count by 1s, you can count by 3s, however you want to do it, as long as each line has the same value between it. And then you're like, oh yeah, these are the ones we just get to color in the middle. Yes. So bracket at -3, parenthesis at 6, and we love interval notation on these because it's just the endpoints. And then again, the only difference with ORs is once you get down to the end of your problem and solve it, you do each one separately. Keep my or in the middle there. Let's see. Let's count every other. But this time they don't come together. If I graph each one separate, x is less than or equal to -1. Less than goes left. X is greater than or equal to 7. That goes right. And again, whenever I see one like that, I'm going to get one of the bigger interval notations. Because I start at the very left, so negative infinity, work my way up to that first stopping point at -1, use the symbol. Ooh, get that in there. And then I'm going to combine that with my union symbol and start up again where the graph starts and write down where it ends. So as it mentions down at the bottom, like I said, I'll have the full-blown version if you want either a copy of it or you want to be able to check or something. I'll have that online. I'll also have some copies in here too. But the assignment to get started on as far as you can, because there'll be a little bit of time tomorrow, we're going to add one more thing to it, is the 1.5 worksheet. This guy, which will end up being on homework check 2, the second assignment that's in there, because the graphing review that you got was the first one. And then there's some book work at the end of that, and we'll take a look at some of these tomorrow and kind of see how things are going. And I will have quizzes up tonight, sometime tonight, on Skyward. You'll get those back tomorrow.